Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-5 Part 2 homework solutions on families of functions.
For number 10, we want to figure out if this function is even, odd, or neither. So we'll plug negative x in for all the x's and see what happens. So comparing it to the original here, this is the even test. Negative x to the sixth is just x to the sixth. Negative x squared is just x squared, so this is minus 2x squared. And finally, we have plus 3. We notice that that comes out exactly the same as the original, so this is an even function. And if it's even, then it can't really be odd. Although I guess you could have a horizontal line that technically has y-axis symmetry and origin symmetry, but that's kind of a silly case. Everything else is either even, odd, or neither. So there we have it. For this one, let's plug in negative x to see if it's even, odd, or neither. Does that give us what we started with? Well, plugging in negative x for all the x's, this is negative x cubed, and this is plus 5x. That is not the same as positive x cubed minus 5x, so it's not even. How about odd? Plugging that all in, do we get the negation of the original expression? Well, this is, again, negative x cubed plus 5x. This is negative x cubed plus 5x. They come out the same, so this is an odd function. Now, in general, you might have noticed that the even functions have all even exponents, and the odd functions have all odd exponents. That only works when you're dealing with polynomials, but it's a lot faster than running the tests, right?
For this problem, we want to figure out whether this function is even, odd, or neither. So to do this, we always test for even first. The even test, basically, we're replacing an x with a negative x and seeing if we do that if the function evaluates to the original version of itself. So I'll write absolute value of negative x plus 5, and I'm trying to figure out, does that equal absolute value of x plus 5, the thing I started with? So what do we do with this negative x absolute value? Well, since absolute value forces everything that comes out of it to be positive, it doesn't really matter whether the stuff inside here is negative or positive. Negating all the stuff inside here and not negating it will give you the same final result because of the absolute value. So you could actually just lose this negative sign and you would end up with something equivalent. So that equals the stuff that we started with initially. Therefore, this is an even function. And if it's an even function, it means it's not an odd function, so this problem's done. For this problem, we want to figure out if this function is even, odd, or neither. So the quick way of doing this, since this is a polynomial, is just to look at the exponents, and if you have all of one type of exponent, it's that type of function. Since we have both even and odd exponents, that means this is going to end up being neither. That's just kind of the quick way of telling. But you can do the tests as well. So if we do the even test, we're going to replace x with negative x. So we'll have negative x squared plus 2 times negative x minus 3. And we're basically going to see if all of this stuff, when we simplify it, comes out to the original function. So let's see here. Negative x squared is the same as x squared. Negative times a negative is a positive. This second expression becomes negative 2x, and then negative 3 is unchanged. And this stuff does not equal what we initially started with. It's close, but initially we had a positive 2x, now we have a negative, so those are not equal, which means this is not an even function. But we still, if we were being rigorous, would want to run the odd test function, which basically we're switching all the x's with negative x's and seeing if it comes out to the original fully negated. So switch all the negatives, the x's to negatives in the original, and then we want to see if this comes out to negative all of what we started with here. So totally negating f of x. So going through here, we again have x squared minus 2x minus 3 on the left. That hasn't changed since we did that with our even test. On the right side now, this is going to be negative x squared minus 2x plus 3. Are these two expressions equivalent? They are not. If all of the signs were reversed, we might have some kind of argument going on here, but even then, it wouldn't work out. These are definitely not the same expression. Because they're not equal, this is also not an odd function. If it's not even and it's not odd, then it is neither even nor odd. For this multiple choice question, we want to know if f of x is even, odd, or neither. Since this is a polynomial, the fast way of telling is just to look at the exponents. Since both of the exponents here are either even or constant, that tells us that this is actually an even function. But we can test it more rigorously with the official test. So for the official test, we're going to plug in negative x wherever we see an x. So we'll write negative 3 negative x to the fourth minus negative x squared, like so. So it really just replaced x with negative x. And then we're going to see if when we simplify this, does this come out to the original that we started with. This is an equals question mark here. So taking a look at our left side, negative x to the fourth power, we have an even power, so that automatically makes this positive. So this comes out, we still have a negative 3 out here though, right? Because exponents happen before anything else. So this is negative 3 x to the fourth for that first term. Next, this negative x squared becomes a positive x squared, but we still have this negative between them out in front there. And taking a look at this expression and what we started with, those are identical, which means that this is indeed an even function, and we're going to choose choice A.
For this question, they're telling us to use this graph to determine whether the function is even, odd, or neither. So this one, just looking at the graph, it has y-axis symmetry. Since it has y-symmetry, that's basically the definition of an even function. So that would be choice A. And again, odd would be origin rotational symmetry, and neither would be, well, neither of those.